Okay, good evening everyone. I'm going to present the SeRoNet project, also a little bit focusing on the core which we have in this project, but also give you a slide overview of what the project is about. I assume the slides will be made available afterwards, so I will not go into every detail. Let's see if this works. Yep. So in a nutshell, what is SeRoNet about? SeRoNet is, in the end, an IT platform which is about collaborative software development in service robotics. So basically, we want to develop software for service robotics, and we want to make this simpler, make this easier, just as Dennis in the Moses call talk also advertised a bit. But we have a specific focus, and we are actually going to do this thing in real. So, meaning our objectives is to really foster the market growth of service robotics and by that also of automation and robotics in general by using standards, by using simplified model-driven software development to basically get the effort of combining systems reduced. That's the basic idea here that we have. So what we have as a vision is to establish a brokerage platform, and we mean web platform here, which you can then use to facilitate business-to-business contact. So we are in the industrial part of it. It's about companies getting in touch with each other by means of describing the systems, the problems, the efforts the different companies have, and then making kind of a matching between challenges and solutions. So we address component providers, software companies, and also hardware companies, which provide robotics parts or software components for robotics. We are addressing system integrators as the middle step, which then basically combines these components into systems. And of course, we address the end users, as these are the guys who have the problem. They want to have something solved, want to have a system being done, and they need to find the right service provider, the right integrator, and the right component provider to get this thing done. So this is the basic idea here of the platform. We have a business-to-business platform for setting up these kind of market. Do we actually need that? I mean, there are platforms out, tons of them. There are marketplaces. So we're saying, yes, we will need this, because when we look at today's robotics market, especially the service robotics market, which has been predicted to skyrocket for the last couple of years, and it simply doesn't happen so far. And we think a problem here is that there is too much effort in building systems, and there's this kind of fragmentation of market also. We have multiple frameworks which are, oops, that was the wrong key. I meant to hit that one. We have multiple incompatible frameworks. We have often kind of a vendor lock-in. You go for a certain thing, and then you basically are married to this vendor, and we have high development costs basically following from this lock-in of different vendors. And also we have this problem of poor adaptability of a solution. Once you created a system, want to change it, basically start again from scratch. This is not so optimal, specifically when you talk about service robotic solutions, which are, let's say, at the front run of what we can do technology-wise. So our offer, or our solution to this is to have this online platform where we have service providers, component suppliers, service robotic users put together into a common ecosystem to allow these to actually interact in a structured way and then jointly work on state-of-the-art moving things forward. Pretty much a bit like a ROS community also works, where you have different universities, you have industries, and bringing them together by one framework, which is basically the ROS framework. So the basic idea is not that different, only we have a much larger scope here. Our technology base, and there's the connection to the talk we had before, is to have composable software components, and we use basically what Dennis said. We use the structures which are developed within RobMoses, where we have all kind of model-driven technologies on the different layers that are designed to simplify software development. And the second thing in SeRoNet is that we have a common structure, base structure, which is OpenCUA as our middleware, basically, and as our framework. And the idea here is that OpenCUA is getting traction, at least in the European market, for industrial automation components. So we think that more or less every component will be an OpenCUA server or client, depending on how you look at it and what you actually have at hand. And SeRoNet should be using this. So basically, SeRoNet components will be compatible with using OpenCUA, so for easy integration in actual line and actual automation systems. There come some things on top of the machine-readable data sheets. There comes functional descriptions of these things, many, many details in the end. To sum this up for a first part, what we talk about in SeRoNet is we talk about business-to-business platform for component suppliers, making their life easier, for system integrators, making their life also easier by speaking common language and having composable systems, and by having these two being satisfied, hopefully also helps the service robotic users. And this works, of course, only by having a platform plus a common technology base, which is based on the RobMoses thing. This is set up out of the Runtime platform, tools, and so on. Now, there's a problem when we talk about platforms. I mean, ROS took 5-7 years or so to basically take up, and the same thing we also have. If you have a new platform, this platform is essentially empty, and no one goes where no one is, usually. So humans are pretty much following the flock, so we need to somehow bootstrap the platform. That's what the core of this talk is about. We have, for that, two pillars. We have, of course, the SeRoNet Consortium doing some initial content, and then we have the open call. It's the funding for the opportunities. And actually, there's the two calls, which I'm talking about now. We have a call for components, where we target component suppliers, no surprise here, funding 100% of the effort in person months, up to 50,000 euros, starting August next year, where you can basically apply for funding to get the effort paid to set up or to convert your existing components into SeRoNet components, using our tools, using our systems, and you gain basically as a benefit, your component is on the platform, you can sell it there, you basically have market visibility later on. The second call is then the complementary one, where we have a call for systems, where we target system integrators and end users, maybe teams of these. It's not yet completely decided. And the idea here is that we have, again, 100% funding. Most likely, is still some negotiations going on in early summer 2020. And these should then implement pilots using the components provided by the other guys in the call before. This is the current setup. So task is, to just summarize for the current core, we talk about creating new SeRoNet components either from scratch or by wrapping existing technology, like existing OpenCUA stuff, existing ROS stuff. We took a lot of effort and are going further on that to making integration of ROS basically seamless, both with the tooling as also with using this thing. Because we recognize there's a lot of body of work in ROS, and especially in ROS-Industrial. The companies went on the train and going with ROS-Industrial since a couple of years now, and all these efforts, all these assets are valuable. They need to be kept and need to be just used also in the other system. So what are the modalities? Just quickly, it's a continuous call mode. We will have a batch every 8 weeks. Every 8 weeks a cutoff. And then can only plan with 3 batches. Time to contract should be pretty fast. 8 weeks after the cutoff, you start running. and the application will be as streamlined as possible, template-based. You just fill out some things. You think about 10 pages or something like for the proposal at most, maybe even less. It's still to be decided. And project runtime will be about 6 months, depending on the proposal, of course. We can also have shorter ones. What we expect quite a lot from you if you want to apply. And this is because we are looking into building community here. So this is not just the platform needs the community. And also we need feedback, just as Dennis just said for Rob Moses, looking for ROS-2 experts right now to get into this structures there, to learn from them. We have the same thing, of course, in SeRoNet, which in a sense is an implementation of the Rob Moses ideas. So we're looking at active participation in the platform, in the consortium. Talk to us, give us feedback. You learn from us, we learn from you. In some ways, as written down here, so we have regular feedback rounds. There are some deliverables to be done. Technical work, of course, has to be done. Pretty much the standard things here on the slide. In the end, of course, we want to have your component in the platform. But the key point is we want to have an interactive process here. Okay, so what are components? Just some examples here, sensors, we talk about actuators, we're talking about software components primarily. So everything, piece of hardware that goes into that should have a driver, which is then the software components we are interested in actually. That are just a random selection if you want. So we are not limiting this by default on anything specific. Come with your ideas and we are happy to listen. What we offer on the return is for the participation and development. We have workshops where you learn about the modeling ideas we have, the same structures as in Rob Moses. Basically, you can visit either Rob Moses or us to learn the same stuff, more detailed or more practical in our size. In SeRoNet, we will have tutorials, email support, fixed contacts, meaning a coach per project, as this is, as Dennis said, usually the best way to do it. And in long term, early access to new technologies, and you have the opportunity to also shape this ecosystem, this infrastructure, define how certain things should work in the thing. So in case you are inclined to actually come to us and apply, so what can you expect? A quick technical overview of what SeRoNet is about. And it's about vendor-neutral structures, it's about open for innovation, it's about a service-oriented way of building systems. What we have here is basically a visualization of the idea which we have. We can have just SeRoNet components. There are these ports here, which Dennis mentioned also in his talk, but this time for SeRoNet, where these are the things where we connect a SeRoNet system, really just plug and play. No integration, just composition of a system. And the tooling takes care of all the nasty bits behind it. And we have different worlds which in SeRoNet can be combined to such a system. You can using OpenCUA components, native ROS components, and so on, all wrapped into a SeRoNet component using the already mentioned concept of a mixed port component, meaning you have something which has two sides, SeRoNet and native, whatever native is. We have tools. This is just some screenshots here. I mean, they're not really telling any big thing. We have tools for component suppliers. We have tools for system integrators where you can define systems, and based on the modeling of these components, you get certain information about what the system will do later on. We have the same for designing what we call services, which is basically the definition of what is a navigation, or what is an ARM, what has it for interfaces, for example. What is a laser scanner, what interfaces has these things, what properties for communication exist here. That's in the service part of the story. When we talk about modeling, and Dennis mentions this, we have two sides. And this is now one of the important things for us. We have the technical modeling, which means how to combine components. That's mostly done by the tooling, but of course you have to tell the tooling some things about it. Then we have the semantic modeling, which Dennis also mentioned, which is not so in the scope of Moses, but it's a central point in SeRoNet, because in SeRoNet it's about this market thing. The rest is just our necessary tool, so to say. But the market is an important thing in SeRoNet. This means you need to describe components in a structured way such that they can be found. So if you have an automation problem, you go to the platform, define your problem, and you want to have now an integrator found who helps you, and you want to have components selected. This requires that your problem is described well and that the components are described. And this is what we have in the second part of the data sheet here. Description of components such that they are identifiable, that you can find replacements basically semi-automatically or even automatically. You have a rich catalog, a catalog with a rich description of components. So that way, to actually have this description of components. That's the key point, and that's also what we want to mainly feedback from the community to help us shaping this language to do the semantic description. We have one, but we want to, of course, check them, verify them with the community so that we got it right and enhance it. Same story, different image. We have a SeRoNet component in the end. This is what you develop in the first call, which is made up of a software artifact, which can be different types, which are actually combined then. And we have this digital datasheet part, especially with the descriptive part, this semantic description which we talked about, which is then uploaded to the platform and available there. We are open with licenses. We prefer open source, just as ROS does, but it's not mandatory. So you can also have proprietary components where only the model is public and the code is closed, and just have a binary blob. We allow that. Also, it's not our preferred way, but it's just the way business works, so we have to have this possibility. Second last slide, if I remember my presentation correct. Another view of how what the idea is, what you can expect when you apply. The idea is to build systems out of these components, and later in the second call basically, and we have kind of a stacked approach to this composability. You can have small components which are composed to something like a robot arm or a robot. You can then again see this robot as a component which you put then into a system, like an automation line or something like this. So basically we have a stacked approach here to have this kind of a recursive way of doing things. If you want to know more about that, talk to me. It's a little bit too much detail for this type of talk probably. And that's already time for questions.
So a question. So are there questions from the audience? And actually I do have a question. Björn, it's a German-funded project?
It's a national German-funded project. We are in talk about opening it wider up. So, I mean, such a platform doesn't make any sense as a national platform. That's probably clear for everybody. It only makes sense if it's open to at least Europe, better the world. For the funding, we try to make sure that at least whole of Europe can apply. Let's see. Currently, this is not the case, but we have still half a year to convince our funding agency.